Thanks all for coming. What do I want to talk about today? Looks a little bit different formatly when it's created, but it should work. So I'm going to talk about first a little bit motivation. Okay, that should be pretty clear, but yeah. Then I will go through some tips how you can improve your compilation speed with a focus on CI. Then I will show you how to analyze your build times. Also some other ideas which we are not really using right now. So this is really most of it that we are using. Then also some tips how to improve tests. In the end, I have to wrap it up. And why is that so small? Well, you can still see it. One question to the audience. Who of us is earning money with programming Rust right now here in the room? Yeah, perhaps like 1/3. Of these people, like for everybody, who is running Rust in a CI system? So continuous integration, building it. And also still, that should be like it. And who of these is using GitHub Actions to run the CI? There is this really good video from Faster Than Lime about why GitHub Actions feels bad, but this is not the topic of the talk. Yeah, we are also running on GitHub Actions, and we had our continuous integration build times creeping up to 15, 20 minutes. And that's annoying. You have a quick bug fix, which you want to bring quickly into production. You wait 20 minutes and you know that it's going to take 20 minutes to wait 20 minutes, and then you learn, you formatted it wrong, do it again. You might learn that earlier. We are running several jobs in parallel, so not really an issue, but you kind of know, okay, till I get my green light, it's 18, 20 minutes. And this is just annoying. It's of course good for coffee consumption and good for, perhaps also good for having breaks. And not so good to stay in the flow and to ship things to make your customer more happy. I'm going to show you a bunch of numbers. This is our in-house project. It's in-memory database system. It interprets like an SQL dialect. It does process mining, but this is all not really relevant for the talk. So you will know a lot more about the patient, but not like so much about his gender, and so it doesn't really matter. But we got around 240,000 lines of Rust code. This, of course, includes tests and so on. We split that up into 37 crates. The later number is relevant. The first number also shows you a little bit about the size of the project. Let's start out with baseline compile speed. So these are not the actual CI numbers. I wanted to iterate fast on these slides and the numbers I'm going to give you. So this is all on this machine. But I tried to replicate basically how our old CI setup was looking. And we were like at around 7 minutes of compiling all tests, not yet executing, and really just that command, which you see there. So here we can start with the first tip. The more the merrier. It's just like the more resources you provide to your build run, like the build scales reasonably well. We also talk a little bit about that, but in general, you can expect if you have more CPUs that it will also build faster for you. This unfortunately also means that you have to take heavy stuff with you. Like probably you're a little bit better with the Mac, but also for local development performance, it's good to have heavy hardware for it. So we went from the first one was just using 2 cores. This is 16 physical cores. And then we went basically down from earlier 7 minutes. Now we are at 2 minutes 40, which actually is quite nice. We could stop here. could go home, have a beer. But of course, yeah, we can do more than that. Yeah, this actually, it really depends probably on which perspective you are coming. If you are coming from a C++ developer, you are used to these build times. It's like, this is actually quite good. If you're coming from Java, Go, Java is of course startup times, but C++, if you're coming from a C++ background, if you're coming from a Go background, you would say, what? It's like, this really hurts my productivity. Probably not, but so, and yeah, I mean, like we want to be attractive for like a lot of different use cases of Rust, and like especially like web development. If you compare that against Node.js, against Kotlin-based applications, yeah, it should be fast, and we can do better than that. So, yeah, that was. I mean, I did like these optimization steps earlier this year. We already had these dependency caching in place. Yeah, it was, and this also helps a lot with the compile times. So it shaves off another minute of our build times, which is nice. Yeah, there is a GitHub action for that, which is called Rust Cache, which basically does this stuff for you. Unfortunately, it's not without problems. If you use that plugin, you should also look from time to time at your builds, because you get rebuilds for stuff. And rebuild, or what I mean by that is that it might pretend to cache, but you cache all your dependencies, but it is either because you are running your project in several configurations, like with different feature effects, it's still rebuilding things. In our case, we had one dependency which was not really compatible with how GitHub Actions caches stuff, and then it basically rebuilt it every time. And if this is like a dependency which is quite deep, and I think this was Ring, so like I think encryption, which is very deep in your dependency tree, all dependencies which are above that, they were also going to be rebuilt. And I mean, here we are just saving like a minute, but quite some of this time you might lose because you are rebuilding it all the time. Yeah, so it pays off to look at this from time to time. I mean, it should still, I mean, because also you're actually downloading the dependencies and uploading this of course also takes time. In general, how this cache action works is that it basically, when basically your target folder is populated, it deletes all project-specific files from this folder, because these are usually not worth caching, because usually you change your project all the time. So, but all dependencies, so the stuff which you only changes when you update your dependencies, these are uploaded. It also caches the files which basically your registry, your cargo registry, local cache. It also actually caches the files in your cargo bin folder. Like a small recommendation here is also to download the files before you basically instantiate this Rust this action, so that you don't also cache these downloaded binaries, because this doesn't really help you. You are going to download them anyway. Yeah, so we are down from 7 minutes to 1 minute 30. Well, we can even do better. Yeah, my third tip is use mold for linking. This shaves another 30 seconds of your build times. And yeah, that is like since October, this is only like a Linux tip, because the macOS linker has gotten significantly faster, which is also a little bit of an unfortunate story, because the developer of Mold also created a commercial version, which is called Sold, which was for macOS. So I really liked it. It was like, hey, I can only earn money, and all the shiny Macs, they get to pay, and the Linux users they get it for free. Yeah, but unfortunately, they really in October released a new version. Linker is significantly faster. Yeah, still a great guy and probably the most knowledgeable person about linkers. And yeah, if you meet him, donate him a beer. But yeah, for us, it is a really huge benefit. In my CI, it only saves me like 30 seconds. But in local development, it is really like one of the biggest increases I've seen. So this is like in our main module, single line change. So you can really, Rust does increment, like it caches also some build results and so on. It doesn't have to do a lot like from the Rust side, but your linker still has to move a lot of files around. And if the first one is without mold, second is with mold, and this is like 3 times faster. And this is even like linking all our tests, and there are, I think, like 3-4 modules depending on that. So you really has to move quite some bytes around. And yeah, mold is a lot better at moving the bytes around. This is that's kind of the current state of our application. At this state, there is like a lot of setup to be done, like downloading the tool chain, actually waiting for a runner to be available. This does not matter more for us anymore. I mean, for local development, if I want to run the integration tests on all my commits and my 60 commit pull request, it is still nice. But yeah, at this point, yeah, for us, the other stuff takes longer than this. This we don't do yet. But it's also like a nice improvement, which is that you basically set your debug configuration to only contain basically line numbers, but not to contain any actual debug information, which would allow you to access the state of variables. So if you set this debug setting in your profile, you cannot properly debug your program anymore, but still your stack traces will contain proper line numbers and so on. So it's still good. Yeah, this saves you even more time. So this is then down to 47 seconds. I will also want to add it to our project. Because I'm not really comfortable to show you the dependency graph of our application, I will later show you like a little bit about cargo and its dependency tree. And by adding these, by only basically having the line tables, you also save a lot of space in your debug binaries. So this is down like from more than half the size of cargo in this case. So, I mean, you will, of course, mostly if you're not developing on cargo, you will, of course, work with a release binary, which is like just 11 megabytes or so. But if you want to build, and especially also in your CI, if you want to copy these things around, archive it also, this might also be a huge benefit. And of course, also having to copy around less stuff saves you time. Yeah, these were like was the generic section, which I hope applies to a lot of projects. Now comes, okay, I'm annoyed with my build times and my project. What can I do about it? And which tools? And because we are used to really good tools in the Rust community, there is cargo --timings, which gives you this graph. This specific graph is the one of our application. You see basically from left to right is basically the blue one is like how many crates haven't been compiled yet. And you basically, like waiting means, because there are of course dependencies between your crate. Yeah. I will also tell it a little bit more later. Also interesting is the orange thing, that's your CPU load. Ideally, this would be like a flat line. So you're really maxing out all your CPUs for the whole build time, because that probably ensures that you get the fastest build. Yeah, for our project, and this is our project, we will see a very similar pattern for cargo, that during the beginning, where you have still a lot of your dependency standing, you can all compile them in parallel, so you can really saturate your CPU. Later on, it comes to your application. You're building like the individual crates of your application, and they cannot really be this cannot be parallelized as much more because you either have chains in your dependency or, yeah, it is often, at least in our application, that, yeah, you simply, yeah, how to put it? Yeah, you have big crates, and these big crates, they cannot do it, and you have only one of them in the end. So that's like also very pronounced for cargo than for our application. Yeah. So I can show you like the output of this command for cargo. This one is really the complete one. I hope this is, I guess it should be visible. So here we really see like all these small dependencies, yeah, usually like smaller dependencies, which are all basically compiling in parallel as much as you have got parallelism left. So this will, of course, also not try on a 16-core machine to compile 64 of them in parallel. And it may really make sure to saturate your CPU. You can also see that in this graph. So yeah, in the beginning it is quite separated, and then you come basically into the section where all your dependencies are done, and now comes your own project. In this case, it's cargo. And there it really drops down to parallelism, to like quite a low parallelism. Here it is basically doing two things at a time. And so this is really the cargo binary. And then it does the test suite later on. Yeah, here it can also compile some library for it in parallel. Interesting, perhaps from the colors here, is you always see two phases for your binaries. The first phase is basically like your Rust compile process with the LLVM toolchain. Is first the Rust compiler translates your Rust source code into intermediate representation. That's basically the format where Rust hands it over to LLVM, and then LLVM translates the IR to x86 code. And one important property of that two-step process is that as soon as the intermediate representation generation is finished, other crates can already start compiling. So as soon as of the crate, which basically the first crate, if that its IR generation is finished, then the next crate can already start generating IR. So there is no dependency, and in the end, the linker, of course, knows how to put all these the generated binaries by the individual crates, how to put them together into one big thing. Yeah. Actually, interesting question why it's not. I think here it actually has to wait for the x86 code to be completely generated. Yeah, so this is basically the version where the dependencies are not cached. Takes quite some time, like 60 seconds. It's also okay, I would say. And here's a version where the dependencies, it only has to basically build the core crates. Yeah, that's way better. I would say, yeah, like that's basically half the time. Yeah, one problem which occurred for me with cargo was that it also has this problem that, I mean, I was only simulating what Rust cache does by basically calling cargo clean. Cargo clean is a command which you can, of course, use to remove your target directory, but can also tell which specific packages it should delete. I basically asked it to delete all packages from the workspace, but if I do that, then it also seems to be deleting stuff, which then in the end caused like dependencies, this whole GIX stuff to be compiled. I didn't investigate it, but I also saw similar problems in our CI. Yeah, I think that's also, yeah, I would be really happy to when cargo would integrate more of these features which you want to have for your CI to remove irrelevant stuff before you basically cache things and so on. perhaps also something that I will look into at some point. Handle. This was a broken one. Yeah. This is basically how you can analyze build times. Yeah. I haven't talked about, there are some kind of cool upcoming features for the Rust compiler. If we look at this, no, this is not the best graph for it. If we look at the timings for this, and especially the CPU load, you see that while here in the front, where basically we are generating IR code, we have a lower parallelism at the point where we're basically translating IR into x86. Why that? Yeah, because like in the current configuration, how the Rust compiler is delivered, the IR generator, the front end of the compiler, so basically before the intermediate representation is called front end, in the compiler parlor, the part which translates IR into x86 for the LLVM, it's called the backend. And while the Rust front end is not in the current configuration, how the lift is parallelized, the backend is, so we see like a higher parallelism while the backend is running. Yeah, and that is basically fixed. You can pass basically that dash that threads and specify a count of threads which you want the Rust frontend to run with. And yeah, then you should actually see some savings. Unfortunately, for our project, we don't. I also didn't see any spectacular numbers for even the example says, yeah, okay, we get some percent, like 30% improvement also for some specific things. For our project, doesn't save any time right now. I think I also didn't see anything better for cargo right now. So yeah, okay, you can use more CPUs, but you can't. It's actually a good question. It's like 530 user time, 480. No, not even. Yeah, we definitely use more CPU, but we don't save time. I mean, it could be also like
for 12 days.
Yeah. So yeah, this is not the thing. There is another development. Yeah, why? Yeah, I mean, why not use a different backend? Like there is CraneLift. CraneLift is written in Rust, so hey, like friends and family. Yeah, why not? Why not use CraneLift as a backend? And I tried that, and this shaves another 20 seconds of our build time. So this is really nice. Yeah, for our project, it stops being nice when I try to run the test suite. Test suite actually runs, but I also didn't debug this to depth. I believe it doesn't really handle panics well, and it's basically panic abort by default or something which is close to that. So yeah, we cannot use that right now, but it's definitely a rising star if you need a fast build system, or if you need a faster Rust build. We might probably, for local development, CI use cases, might use CraneLift. I would also be like a little bit reluctant. I mean, we are anyways always doing debug builds for CI use cases, local development. In production, we run release, which is like quite dissimilar sets of binaries which you create. I mean, like the differences between the debug build and the release build, of course, are crazy in performance. Also, if you actually look at the IR generated for a debug build, it is full of debug information. And like, if you really want to understand what the compiler is doing, don't use it. Turn off debug information. If we want to understand it at the IR level, it removes so much noise. And on the other hand, like the inlining capabilities of LLVM, they really cause also your x86 structure to change so much. So we really have to be trusting that LLVM is doing the right thing, that the Rust compiler is doing the right thing. So perhaps we can also trust in a different backend, like an entirely different backend from what we would run in production. There are other tools which you can use. if you run into these kind of issues like long build times, I mean, especially if you're using heavily generic stuff, then you can get quite easy amplification. You add one type and you get a totally new world of the stuff, the structs instantiated in your code base. And this can be also quite creeping at some point. I mean, we have one module in our code base which quite on purpose does that we basically, that's SQL window functions. They can have quite some settings in the range expressions, like the window boundary expressions. So we are instantiating some sets of our code 50 times here. Yeah, you can use LLVM lines. Is basically a tool which you run on a package, and it tells you how often, like how many lines in IR you generate, and it also tells you like how often like your different structures or functions are instantiated. So you can find like really heavy hitters which you might not even have intended to instantiate that often. And also, if you want to make your code more dynamic and so on, this tool can help you with that. So yeah, this is another tip for CI. Yeah, don't build cargo make any tools which you use in the CI. Just download it. There is this nice action which basically installs it for you. Yeah, this is just for completeness. If you should look at it, I'm not going to go through it. Yeah, I talked a lot about compilations. Here now, just two tips, or one problem which we ran into, and one tip for making your tests faster. We had, like before I looked into this, we had test runs which took 2 to 3 minutes. And this was caused because we were creating, for every single test, we were creating like a whole database pool with like 8 connections or so to SQL, to Postgres. And this seemed to be locking up at some point with this high demand, lots of connections be generated. So the test, and sometimes the test would even fail, but it also took like 2 to 3 minutes. After I was done with that, it took 15 seconds for the whole test suite to run and no locking up. Yeah, just like having a shared resource as a database pool. And yeah, the last tip is, there is this serial macro which you can use if you don't want to run your test in parallel. Avoid that. It's, of course, sometimes, but in general, a good design test suite should not require that. If you use it, you are not only blocking this test from running in parallel, but you're also blocking one thread of your test suite from running other tests. So yeah, not really recommended. Yeah, quite generic. So like your doc tests might be slow for some reason, don't run them, but also something which we had. Yeah, here you see like a nice summary. Like blue is our internal project, how the times improved. Red is how the cargo times improved. Here are some resources. And when you want to get into touch, my surname and both big platforms, these two big platforms. Yeah, there will be no Q&A, but I still wanted to show that slide.